The quintessential, classic, giant movie monster King Kong. Came out in 1933. Within 25 years, of course, it's already the source of parody. And about that same stretch of time, monstrous disasters started befalling all of the DC characters. Giant-sized Batman, giant-sized Wonder Woman. It also started happening to the B-line superheroes. Even the sidekicks. Do you realize how utterly dangerous it is to be Superman's best pal? And for Superman, it happened when he was Super Baby, it happened when he was Superboy, it happened when he was Superman, more than once. You can imagine at the meetings of the Justice League of America, they'd get together, oh, this morning I woke up when I was a giant size. I hate that when it happens, oh my God. And of course, Bruce Banner mutates into the Hulk, Hank Pym into Giant Man, or is it Goliath? The next generation stature. I don't know how plausible this is to a biologist, but I want to look at it from a physicist's point of view. Hey, here's a phrase you often see in the personals. I never read them, but somebody, Seeking, blah, blah, blah. Weight proportional to height. What the heck does that mean? And is, in fact, that a desirable trait? Take a look at this block. Perfect cube, h high, h wide, h thick, and it weighs a total weight W, okay? Let me stack two blocks, identical blocks up, and ask, how much would this pair of blocks now weigh? 2W, right? Very good. If you put those two shapes side by side, would you argue that these two blocks are in perfect proportion? The one on the left is sort of squat, and the one on the right is tall and thin, right? That's not perfect proportion. Perfect proportion must mean as it gets taller, it gets thicker, it gets wider. If you double the height, you should double the width. You should double the thickness. In fact, if you did this, this truly double-sized block would weigh how much? 8 times, right? Because you can count it's the equivalent of 8 blocks now. Or more generally, because there's nothing magic about the perfect cube, again, as I said, if I'm going to change it proportionally, I'll have to increase the height, width, and length all the same way. So if the original volume was height times width times length, this expanded volume of the double block should be double the height, double the width, double the length. So not 2 times the volume, but 2 times 2 times 2, or 2 cubed times the original volume, in this case 8. So is weight meant to be proportional to height? Weight is proportional to the cube of height. That means for every % increase in height you experience, your weight should be boosted by 3%. For every 5% increase in height, by 15 or 16%. 10% increase in height should be accompanied by a 33% increase in weight. Okay, here's a lesson you've probably learned from playing with blocks. This row of blocks is able to hold itself under its own weight, but not if I turn it that way. Apparently, the thickness of the block has something to do with its strength. Here's a very rigid piece of PVC pipe, and here's an identical pipe, but of a larger section. Well, this one is solid and hard, and I still hurt. This one, same stuff, but is unable to hold its own weight up like this one. In fact, I've got several pieces of wood dowels, and that you'll notice that the thinnest of them droop the most. You need to be thick enough to be able to support your own weight, suggesting that the strength of material depends upon its thickness. But recognize that I don't mean thickness one-dimensionally. If I want to be able to have an arm or a leg that can lift things like their own weight, or particularly if I'm trying to lift something heavy, I don't want to worry about having to always position my bones in a certain direction before I lift them for fear of this happening. So thickness can't just mean fat in one dimension or one direction. Thickness, as my drawings on the screen suggest, have to be a thickness sort of in all around directions, or cross-sectional area. So strength depends upon, stable strength depends upon a cross-section. And cross-sections are areas, and the area, for example, of this rectangular bone would be d times d, or d squared, and of this circular cross-section bone would be pi r squared, which is half the diameter. In both cases, you'll notice that the thickness, as measured in cross-section, depends upon the square of the thickness. So strength depends upon the cube, upon the square. So, for example, doubling the thickness of a section of pipe, will that double its strength? That'll do what to it? It'll increase it by 4, because both of its dimensions in cross-sectional area have to be increased, thickness and width. Tripling a section of pipe would make it 9 times as strong, and a section that's 10 times as thick should be 100 times as strong. Hey, take a look at this. Adult human male, adult gorilla. They are considerably different, but not much different in height. Gorillas are little more than 2 times more massive than a human. They're not twice as tall, they're same tallness, but they're a lot more massive. And you'll notice the skeletons are not identical. Here are comparing the femur bones of a grown human male and grown gorilla male. Little thicker. Notice those are not in proportion. The gorilla's is fatter. And fatter by an enough that guarantees that it should be a little more than 2 times as strong, which is perfect because a gorilla weighs a little more than 2 times as much as a human. Nature has not wasted any material in building the skeleton of a gorilla. It's just thick enough to support the gorilla perfectly. So the gorilla can do the same sort of actions we can do. It can support its own weight just as well as we can. And you can also see that in nature, they get it right. Dinosaurs are bigger than us, but we don't just scale our bone structure to theirs to get bones that are strong enough to support dinosaur masses. They're much, much thicker, and they need to be. King Kong is 5 times as big as a normal full-grown adult gorilla. So he must have weighed 5 times as much? 25 times as much? 125 times as much, right? But he scaled up in perfect proportion. Just look at that. Which means his bones, if they scaled up in perfect proportion, would be 5 squared times as strong. So while a full-grown gorilla's skeletal structure is made up of bones thick enough to support his own weight perfectly, King Kong, his bones are 25 times stronger, but his body is 125 times more massive. King Kong could not have supported his own weight. His skeleton would have been crushed by just the act of standing. Hey, what about the Hulk? Gray Hulk is about 7 times more massive than Bruce Banner, and Green Hulk 800 times. To support those increases in weight, his bones would have to grow by a factor of 2 and more than 2.5, almost 3 times. Hey, but just look at the picture. Hey, they got this one right.